Welcome back. Today I am going to derive the equations of motion for constant acceleration. According to Newton's second law, if the net force acting on a body is constant, then similarly acceleration, which is F net by m, mass of a body will obviously be constant, net force is constant, so acceleration will be constant. In that case, we can find out the relation between a velocity at a particular instant, let it be t1, and another velocity at an instant t2. We can find the relation between velocity at t1, velocity at t2, the constant acceleration, and t2 minus t1, that is the time taken for the change in velocity. We will get total 3 equations relating all these things, and we can use those equations to solve problems involving constant acceleration. Best example of constant acceleration is free fall. When a body is under free fall, the only force acting on the body is the force of gravity. In that case, we can derive these 3 equations using 2 methods. First is an easier one, the graphical method, and second is the calculus method. So let's start. We know that the graph in which a straight line is there, means a graph of a straight line, the slope of that straight line is constant. That means it will not change with time. So which graph will give us the acceleration? Velocity time graph. If acceleration is constant, that means velocity time graph will also be a straight line. So let's start the derivation using velocity time graph. So this is a graph. Here we take the time, and here we will take the velocity. Okay, and at time t1, let the velocity be v. So this is a straight line. Drawing is not perfect, but yes, it is a straight line. Here initial velocity is u at time t1. At time t2, the velocity is v. So we call this the initial velocity, we call this the final velocity. This is the change in time. t2 minus t1 is the change in time, that is the time interval or the time taken for the change in velocity. Let us take it to be t. Okay, now let us draw a line parallel to this. This is parallel. Let this angle be theta. So what is the definition of slope? The definition of slope is tan theta is equals to perpendicular by hypotenuse. From here also we can see perpendicular by hypotenuse. What is this perpendicular? This length, it is v minus u. All this is in the vector form. Okay, what is this? We see here this one is t. So here tan theta is equals to v minus u by t. For simplicity, I am not indicating the vector sign, but velocity and acceleration, here it will be in the vector form. Here tan theta is the slope of this velocity time graph, which is equals to acceleration. So here we come with the first equation, v minus u is equals to at. This is the first equation of motion for a body moving with a constant acceleration. What is this t? V, final velocity. Final velocity. What is this u? It is initial velocity. What is this t? Time for change in velocity. And what is this a? It is the constant acceleration with which the body is moving. So let us remember this first equation. We will use this to derive the other two equations. So let's proceed.